Here's my attempt at explaining what a large language model does using a single blank piece of paper. So if you can imagine this blank piece of paper as the space of all possible ideas that humanity has ever produced. It's very small, but the space of all possible ideas humanity has produced so far is also very small. Anyway, what a large language model does is that it figures out the structure or the geometry of this space. But in the real world, it's messy. It's all folded up. It's all crumpled. It's all mixed in. Now, if you take the real world and try to translate one idea from one point in this crumpled up space to perhaps another point in this crumpled up space, it's going to be very messy, very difficult. But what large language models are doing with neural networks is essentially understanding the complex representation of this huge and complex space and unfolding it to figure out how you can get from one point in this space to another point in this space and the paths in between. So if you imagine the same program written in Python over here, the same program written in JavaScript over here. Now, if you fold it this way, perhaps that point on this leaf and on this leaf, the Python leaf, and imagine this as the JavaScript leaf. It's just represented in two different points in this complex space. So here is the messy real world that a language model attempts to understand and navigate and figure out the paths in the real world with the messy language, the messy representation of ideas in different languages. But a neural network is essentially trying to understand the geometry of how it folds, how everything relates to each other, even though it's not very obvious when you look at it from a human point of view. That's it. That's what neural networks are doing, in my view. Obviously, there are many ways in which you can interpret it and try and understand it. This is how I understand it. Thank you. See you in the next one.